Hi, hello friends, welcome to Sandeep'S diary. In today's class, we are going to see the first and the foremost chapter of class 10, that is chemical reactions and equation. This chapter is a basic for your class 11 and your class 12. And to understand the concept more easily, I have divided this chapter into three main parts. Let's see what are those. First, part 1, Introduction to Chemical Reactions and Equation. So I will be talking about what is a chemical reaction, what is a chemical equation, how to balance a chemical equation, and those all in part 1. In part 2, we are going to discuss the various types of chemical reactions. And part 3, Effect of Oxidation Reaction in Everyday Life. That is about corrosion and rancidity. Okay, let's move on to the chapter. So now let's move on to the introduction of this chapter, that is physical state and chemical state. What is a physical state? A physical state is a state where we can reverse the process. For example, freezing of water. Freezing of water is an example of physical state. But if we talk about chemical state is a state where the process is difficult to be reversed. For example, let's take digestion of our food. Whether it is reversible, no, right? So that is a kind of chemical state. Now you take a screenshot of this. So now let's talk about chemical reaction. A chemical reaction definition goes like this. A change in which one or more substance or substances, that you simply call it as reactant, to form new substance that you call it as products is called as chemical reaction. So one substance decomposes to form products, or two substances react to each other to form a product, or three substances reacting with each other to form a product. So formation like this by reacting species is known as a chemical reaction. So let us understand this by an example. Sodium is represented as Na, that is reacting with water, that is H2O, to give the product called NaOH, sodium hydroxide, plus H2 gas liberation. So here sodium and water are reacting with each other, so they are called as reactants. And the newly formed substance is sodium hydroxide and hydrogen gas, and those are called as products. So this is the first example. The next example is magnesium that is burnt in air. That is nothing but magnesium is reacted with oxygen to form magnesium oxide. Okay, magnesium reacted in air to form magnesium oxide. This is nothing but magnesium reacting with air. Okay. So now let's understand the characteristics of the chemical reaction, or you basically how to identify whether a chemical reaction has occurred or not. So first is change in state. See, 2H2O plus O2 gives 2H2O. That is hydrogen plus oxygen gives water. See, gas and here gas, but it is changed to liquid. So the state is changed, gas to liquid. Second thing, change in color. 2Pb3O4 decomposes to form PbO plus O2. Pb3O4 is in red color, but PbO is in yellow color. So a chemical reaction has occurred. Next, evolution of gas. Zinc plus H2SO4, that is sulfuric acid which is dilute, and that forms zinc sulfate plus H2 gas. See, here H2 gas is evolved out. So evolution of gas has occurred. Next, change in temperature. Temperature change also is a major factor. That is, one is exothermic and one is endothermic. Exothermic process is a process where heat is evolved out. So for example, C6H12O6 plus 6O2 gives 6 carbon dioxide plus 6 water and heat is evolved out. But whereas in endothermic, heat is absorbed. So calcium carbonate plus heat is absorbed in, and that forms calcium oxide plus carbon dioxide. So this is about change in temperature, and the final one is formation of precipitates. Precipitates also can be formed so that we can easily identify whether a chemical reaction has occurred or not. So now let's try to understand what is a chemical equation. So chemical equation is nothing but a symbolic representation of a chemical reaction. Symbolic representation of a chemical reaction is nothing but a chemical equation. First, let's try to understand what is a word equation. Word equation. We will understand through an example. Zinc plus hydrogen chloride gives zinc chloride plus hydrogen gas. This is a word equation. Zinc is added to hydrogen chloride is forming zinc chloride plus hydrogen gas. Hydrogen chloride is otherwise called as hydrochloric acid. Yes, now let's learn the chemical equation. Chemical equation goes like zinc. Zinc is Zn plus hydrogen chloride, hydrochloric acid. It is nothing but HCl. Zinc chloride, zinc Cl2 plus hydrogen gases separated out. So this is an example of a chemical equation. Hey guys, I know you're eager to solve your own problems. Here is a do-it-yourself question. Try it and comment it down in the comment section. So now let's understand the difference between a balanced chemical equation and an unbalanced chemical equation. A balanced chemical equation is nothing but equation which contains equal number of atoms on each element on both sides of the arrow. That is, so if we take magnesium, here 2 magnesium atoms are there. Here also 2 magnesium atoms are there and 2 oxygen atoms. So this will go here. So 2 oxygen atoms are there. So on both sides of the arrow mark, left hand side as well as right hand side, the equation is perfectly balanced. But whereas unbalanced chemical equation is an equation which do not contain equal number of atoms on each element on both sides of the arrow. That H2, here 2 atoms of H2 is there. Here oxygen 2 atoms. Here hydrogen 2 atoms, but whereas oxygen only 1 is there. So this is a unbalanced chemical equation. So now let's try to understand how to balance a chemical equation. So we will talk with an example. Magnesium reacts with oxygen to form magnesium oxide. First thing that you have to note down is we have to list down all the atoms which is present on either sides. So this is your left hand side, that is your reactants. This is your right hand side, that is your product. Let's write reactants as R and products as P. And magnesium. How many magnesium atoms are there? Just only 1, right? Only 1 magnesium atom. How many oxygen atoms are there? 2 oxygen atoms are there, right? In your reactant side. Coming to product side, how many magnesium atoms are there? There's only 1. And oxygen also 1. So what will I multiply to it so that I will get 2? I'll multiply 2 to it, so I'll get 2, right? So I have to place this 2 in front of this compound only. So I will have to place 2 over here. Now you can understand clearly that magnesium now has become 2. Now magnesium has become 2 and oxygen also becomes 2. So oxygen, there is no problem. But here I have only 1 magnesium, right? How will I balance this? So I will multiply 2 to it to get 2. So I will put 2 over in front of the magnesium, 2. So here now you can clearly see that two magnesium atoms, and here also two magnesium atoms, right? Fine. Oxygen atoms 2 and oxygen atom 2, right? So this is now our completely balanced chemical equation. Now we'll try to balance a little bit complicated chemical reaction, that is Fe plus H2O gives Fe3O4 plus H2 gas. See, number of ferrous atoms. So let's write reactant side, that is iron atom 1, hydrogen, that is 2, oxygen, that is 1. Here ferrous, that is iron, is 3, oxygen is 4, and hydrogen is 2. Right? So now it is very much clear that Fe plus H2O gives Fe3O4 plus H2. Ferrous atom is 1 and ferrous atom is 3 over here. Now if we try to balance the highest possible number, that is here it is 4. Let's try to balance with 4 first, so that our equation will get more easier. So if we balance with 4, where is oxygen? Here it is oxygen. So what will I put over here to get 4 oxygen atoms? So I'll place 4 over here. Now you see 4 oxygen atom is perfectly fine. But whereas 4 into 2, 8 hydrogen atoms came. So to make it hydrogen as 8, so what will I place over here? Yes, absolutely, that is 4. So 4 into 2, 8 hydrogen atoms will be placing. Now here 3 ferrous atoms are there. 3 ferrous atoms are there. So what will I place over here? Yes, 3 ferrous atom I will place in before Fe. So that 3 ferrous atoms over here, right? 3, here also 3, 4 oxygen atoms, right? 4 oxygen atoms, and 8 hydrogen atoms, and 8 hydrogen atom. Now this is a perfectly balanced chemical equation.